If you line up the 10 with the 10, a nicer atmosphere is created on the CRP-5, and in the airspeed window, a pressure altitude of 0 feet will line up with plus 15 degrees Celsius. It may be seen that rectified airspeed on the inner scale, for example 170 knots, is the same as true airspeed on the outer scale. TAS can also be calculated in the non-ice atmosphere. For example, pressure altitude is 18,000 feet. Correct outside air temperature is minus 30 degrees Celsius. RAS is 170 knots. What is TAS? Using the airspeed window, line up 18,000 feet against minus 30 degrees Celsius. Rectified airspeed is shown on the inner scale marked in red here, and true airspeed is marked in red on the outer scale here. 170 knots RAS on the inner scale is lined up with 220 knots TAS on the outer scale. Let's look at another example. Pressure altitude is 35,000 feet. Correct outside air temperature is minus 47 degrees Celsius. RAS is 280 knots. What is TAS? Using the airspeed window, line up 35,000 feet against minus 47 degrees Celsius. This time, using the red cursor, 280 knots RAS on the inner scale lines up with 500 knots on the outer scale. This is an uncorrected TAS. Using the compressibility correction window, TAS of 500 knots divided by 100 equals 5. 5 minus 3 equals 2. 2 what? It is 2 divisions to move the arrow pointing at the compressibility scale to the left. This has the effect of decreasing the initially observed TAS of 500 knots. Now reposition the red cursor through the initial RAS of 280 knots on the inner scale and read off 480 knots corrected TAS on the outer scale. If 10 on the inner scale is lined up with any number between 575 and 675 on the outer scale, an arrow labelled Mach number index appears in the airspeed window. An example best demonstrates its use. If temperature is minus 45 degrees Celsius, Mach number is 0.82, what is TAS and the local speed of sound? Align the Mach number arrow with the correct outside air temperature in the airspeed window. Mach number of 0.82 on the inner scale lines up with a TAS of 482 knots on the outer scale. Opposite the Mach number of 1.0 is the TAS of 588 knots, which is the local speed of sound. Local speed of sound and Mach number calculations may be achieved using an electronic calculator with the following formulae. Local speed of sound is equal to 38.94 multiplied by the square root of temperature in Kelvin, and Mach number equals TAS divided by local speed of sound. For the same example, Local speed of sound equals 38.94 multiplied by the square root of 228 Kelvin, which is the minus 45 degrees Celsius plus 273. This results in a local speed of sound equaling 587.98. The Mach number of 0.82 equals TAS divided by 587.98. Solving for TAS gives 482 knots.